Okay, here for the last part where we're going to go over the graphs of tangent and cotangent functions. So the tangent and cotangent functions each have a place where they are undefined. So for tangent, it is at pi over 2 plus pi n, and then the cotangent is for pi over n. So think about where that is. If you think of the unit circle at pi over 2, the point is 0, 1. So if you're finding the tangent, you would do 1 divided by 0. That's why it is undefined, because you can't divide by 0. When you think of pi, that is here at 1, 0, the cotangent would be formed by doing x over y, because it's the reciprocal of tangent, which is y over x. So if you did here 1 divided by 0, again, you would get something as undefined. And so that occurs every pi units there. It's also going to happen here at, oh sorry, this is negative 1, 0. It's also going to happen here at 1, 0. So this is like 0 plus pi n. So if you plug in 1, you'd be at pi. If you plug in 2, you'd be at 2 pi. So you would keep hitting those 2 points. Just like at pi over 2. If you added pi to pi over 2, you would be at 3 pi over 2, which again would give you a point such that when you calculated the tangent would give you undefined. Now on the graph, these are represented by vertical asymptotes, and because the tangent and cotangent, they go on forever, there is no amplitude. We say the amplitude is undefined. So you can't see the asymptotes in here, just like we did before when we were doing log functions. Your asymptotes are going to occur here. So this is at pi over 2. It would be x equals pi over 2 here. And then they keep occurring every pi units. So that means the next one would be at x equals 3 pi over 2. And then that would continue. You could also go on the left side. If you go on the left side pi units, you'd have x equals negative pi over 2, and then x equals negative 3 pi over 2. So those are your asymptotes, and they are undefined there. You also have them for the cotangent function. If you look at the cotangent function, the placement is different because the first place where you have undefined is at 0, so x equals 0 is an asymptote, but then those occur every pi units as well. So at x equals pi, that would be one. At x equals negative pi, that would also be an asymptote. So remember, we use the dashed lines for the asymptotes on there. And then they do tell you the domain, so they're excluding the part where the graph is undefined. That's where our asymptotes are. And then the range from negative infinity to infinity. Now the period for tangent is pi, so that's a little bit different because cosine and sine were 2 pi. Tangent and cotangent repeat themselves every pi units. And this is where are the x-intercepts on the graph of the tangent function. So if we look at the first x-intercept here, the first x-intercept would be at 0, okay? And then they occur every pi units. So we would say that this is your first one on the right side. X-intercept is 0. 0 plus pi n is where they'd occur, which is the same thing as pi n. So the x-intercepts occur every pi n units on tangent. And then for the cotangent, the first x-intercept is going to occur here at pi over 2. And then those occur every pi. Okay, so this would be pi over 2 plus pi n. All right, and then the transformation boxes are going to let you know your new formula to find the period. So to find the period for tangent or cotangent, instead of doing 2 pi over b, you just do pi over b because it repeats itself every pi. And then they also tell you where the asymptotes are located. So pi over 2b plus pi n over b, where n is an integer. And then for the cotangent, again, the period is the same, and then the asymptotes are at x equals pi n over b. So you can do that to find your asymptotes. All right, so we are just going to do one of the tangent graphs, and then we are going to identify the period, the x-intercepts, and the asymptotes. So the period, x-intercepts, and the asymptotes. So the first thing is identifying the period here. Okay, so your period, you're going to take your b value. So b is 1/3. So if we do pi divided by 1/3, we're going to multiply by the reciprocal, and your period is going to be 3 pi. Okay, now we're going to identify the x-intercepts. Okay, so on the graph of the tangent, an x-intercept occurs at 0. Because the period is 3 pi, okay, the x-intercepts are going to occur at 3 pi n, where n is an integer. So in the original graph, they were at pi, but now the period is 3 pi, so that's how often they are going to occur. Where are the 3 intercepts? Where are 3 intercepts on the graph of g of x? You can graph it, and then you can go ahead and identify them that way. But because the first x-intercept occurs at 0, and you have 3 pi, we know that one's going to occur at 0, one is going to occur at 3 pi, and then the other one is going to occur at -3 pi. Again, that is something that you can get from the actual graph itself. So you can also multiply them by the reciprocal of b. So if b is 1/3, the reciprocal is 3. What's happening is you're having a horizontal stretch by a factor of 3, and then you could take the tangent x-intercepts, which are 0, pi, -pi, and multiply them all by 3, which would be 0, 3 pi, and -3 pi. Again, that is going to show up when you graph, so feel free to identify them that way as well. All right, now we're going to identify the asymptotes. So we know that our b value is 1/3, so we're going to use our equation here that says x is going to be pi over 2 times b, so this is 2 times 1/3, plus pi n divided by b, which again is 1/3. And then we just have to simplify. Okay, so this is pi over 2/3, which again, you're going to multiply by the reciprocal, so this would be 3 over 2 pi, plus multiply by the reciprocal. This is going to be pi n times 3, which is going to be 3 pi n. So we would say the asymptotes occur at 3 pi over 2 plus 3 pi n. And again, that is something that you're going to verify with the graph, but look at this, right? The 3 pi, that is the period. Okay, so now we can graph using what we know and our calculator. So you could go ahead and put your intercepts. So like you know that an intercept's going to be at 0. Because this is 3 at 3 pi, we can label these by pi. So this would be pi, 2 pi, 3 pi. My computer did just got the idle screen, so I'm not sure if it's lagging at all here, but hopefully it's not that noticeable. Again, you can also plot this and you can just use your table, and that is perfectly fine as well. Okay, so I'm at 0 here, and if this is pi over 2, this is 3 pi over 2, right? So for my intercepts, I'm at 0, I have one at 3 pi, and then I have one at negative 3 pi. And then this is we're gonna go by 1, so this is gonna be 3 and negative 3. I'm gonna put my asymptotes in, so the first one occurs at 3 pi over 2, and this is gonna help me know where to make my curves, and then they occur every 3 pi n. So this would be 1 pi, so 2 units make 1 pi, right? So this would be 1 pi, 2 pi, 3 pi. And if you look from 0, it's 3 units this way, 3 units this way. And then that would continue. It would be 1, 2, 3, 4, 5, 6. So this is going to be your next one. So 6 units on the graph that we created. 2, 3, 4, 5, 6 makes 3 pi. And our asymptotes occur every period here. And then to make your other ones, you can use your table. So I'm going to put in my 1/2 tangent. The 1/3 I am going to put in parentheses, so I have 1 divided by 3, close my parentheses, x, and then I can close these, and I'm going to use my table. Okay, so here's pi over 2. At pi, I'm at 0.86. I'm at 0. I'm at negative 0.86. And I'm also going to set my window. So if I'm looking at, really, if this is 3 pi, this is 4 pi here. So I'm going out to 4.5 pi, or I could just do 4 pi. And then I'll keep it pi over 2, but this I can make longer. Okay, and then we will graph. Oh, so my calculator is a little bit older, and if you have the TI-83, they actually put those in for you. They actually put in the asymptotes, and if you have one of the newer ones, you won't see that. You'll just see the curve part. Okay, so this is gonna go up, and this is gonna follow this line. And that part doesn't need to be as an exact. What I do is I do like half of a parabola up and then half of the parabola down, and it ends up following your asymptotes. Half of it up, half of it down. All right, you have a short homework assignment because you'd have longer notes this time, so that will be available for you, and I'll even put some graphs like this on there so you don't have to make the graphs every time. All right, thanks. Have a good one. Bye.